The problem is the same in almost every country the world over: the continually increasing traffic load. Despite the rejoicing at the opening up of the borders within the European Union and Germany's reunification, the consequences have not been entirely good news. These developments have resulted in a corresponding explosion of traffic generation. Tens of thousands of trucks with increasing axle loads are on the roads day and night, supplying hundreds of millions of people with industrial goods and commodities. This not only leads to congestion and slow-moving traffic, but also to road damage, and the evidence of this damage is everywhere. The costs for repairing our transport network have meanwhile reached gigantic proportions. The public coffers are hardly able to cover these costs anymore. For this reason, it's vital to use technically and economically efficient methods when it comes to road and highway construction. We at Kirchner have accepted this challenge. With our compact asphalt technology, we've developed a method that enables the top two asphalt layers to be constructed in one work process, thus significantly improving the quality and increasing the life cycle of the roads and highways. Before we demonstrate with practical examples, we're going to show you on our flowchart how the asphalt is laid with our new compact module paver and feeder. First of all, the four-running feeder machine fills the binder hopper. In our computer animation, the binder is colored green. Then the feeder and conveyor belt take the wearing course material to the container and fill it. This material is colored red in our animation. Now the two top asphalt layers can be laid in one work process, hot on hot. Let's take a look at how a conventional road is constructed. Here we can see the separate asphalt layers. And in comparison, the compact asphalt. Since deformations occur mainly in the top asphalt layers, the constructing of thinner wearing course layers increases the road surface's durability and deformation resistance. But let's move on from the theory and take a look at the surfacing machines. The basic machine is a conventional road paver with a variable high compaction screeding beam. In addition to this comes the wearing course paver module. It's designed as a self-supporting construction with its own energy supply, a heated 15-ton storage container, separate material transport unit, and a variable screed which can also be adjusted to suit the level required. The 30-ton storage hopper, the modular machine technology is designed in such a way so as to enable fast transport from one construction site to the other. We're going to show you how all this works in practice by demonstrating various operations. Come with us. The green lamp signals that binder mix is being put into the large material hopper. The compact module paver is filled alternately with binder and wearing course material using the paver feeder. It's the end of September 2000. We're on the A38 Autobahn near Leipzig, a new motorway section. The binder being used here, with the technical specification 022S with PMB 45, is being laid with a thickness of 8 centimeters. All the conventional control techniques can be used with the compact module paver. When the binder hopper is full, the lamp switches to red. Now the wearing course mix is required. An individual material flow is a prerequisite when using the compact asphalt construction method hot on hot. We have therefore designed the feeder in such a way that it's completely emptied before another material mix is loaded into it. This rules out any unintentional mixing of different surfacing materials. The storage hoppers only contain exactly what they are meant to contain at any particular time. In this case, it's 15 tons of wearing course material. As soon as the wearing course material's hopper is full, the feeder arrives. The conveyor belt is lowered in order to prevent any demixing of the materials caused by dropping them from too great a height. Now it's again time to fill the binder material. In the meantime, of course, the asphalt surfacing continues at a constant speed. The asphalt binder is laid using the front high compaction screed, while the built-in screeding beam at the back completes the wearing course during the same work cycle. Here in Leipzig, the binder course consists of stone mastic asphalt Q11S with a thickness of 2 centimeters. The binder course underneath it is laid with a thickness of 8 centimeters, as previously mentioned. The idea of this innovative construction method is to lay both the top asphalt layers simultaneously. This guarantees the best possible layer interlocking and bonding. In contrast to the conventional method of laying the wearing course onto a cold base layer, the hot asphalt course that's used here increases the compacting time for the subsequent rolling process. Roads where the compact asphalt construction method has been used will certainly meet the transport demands of today and tomorrow. These roads will be distinguished by their extreme wearing stability and even surfaces. You've seen how smoothly the surfacing process runs here in Leipzig. Let's move on now to another construction site and follow the low loader. It's the weekend and we're in the Harz region. The B244, a major road, is completely closed to traffic in the Elbingerode area. The road surface is to be renewed for a length of about 1 kilometer across its entire width. On this road section we are placing the binder layer with the specifications 016S with a thickness of 6 centimeters and the wearing course with the specifications 011S with a thickness of 2 centimeters. The built-in screeding beams used here are tried and tested serial components. They are producing both layers at a width of 7 meters and with a high density pre-compaction, as seen here in roof profile. In order to achieve the required first grip on the stone mastic asphalt constructed here, stone chippings are rolled into the surface with the last rolling cycle. The main advantages of this process are the resulting quality and deformation resistance of the constructed carriageway and the extremely short construction period required. The surfacing in the Harz took only 7 hours. It's clear that compact asphalt is streets ahead of the conventional asphalt construction methods. It's an impressive process, both technically and economically. By significantly reducing the construction time and the low personnel requirement, costs can be reduced dramatically, and the economic benefits increased as a whole. Let's move on. Our next construction site is at the A4 Kirchheim to Dresden Autobahn at Schorbaer Berg. Since reunification, this has become one of Germany's most crowded autobahns. In order to keep the traffic flowing, 2 lanes have to be renewed over a total length of 6 kilometers. For the 24,000 square meter area that had to be resurfaced, we needed a total of 5,500 tons of mix. The binder layer, with the specifications 022 with PMB 45, is laid with a thickness of 8 centimeters, and the wearing course made up of stone mastic asphalt 08S with a thickness of 2 centimeters. The road surface at this section is subject to particularly high load levels, as it has a 6% gradient and a great deal of truck traffic. For this reason, the client decided to renovate the road with compact asphalt. The evenness of the road is proof of the surface quality, its excellent compaction, and the strong first initial grip, thanks to the even distribution of the stone chippings. Even on this main east-west motorway, this method of construction ensures that construction time is significantly reduced, and this benefits all road users. In just a few hours, conditions on the A4 will return to normal. We're on the road again. Our surfacing team with paver and feeder is en route to Northern Europe. The next construction site is situated near the Swedish city of Göteborg. Skanska Industri, one of the largest construction companies in the world, has contracted us to renovate the urban motorway in both directions for a length of 4.5 kilometers. Engineering specialists have come from all over Scandinavia to watch the laying of 10,000 tons of compact asphalt and to find out about the benefits of using this method. In the northern European countries, asphalt surfaces are suffering from increasing traffic loads as well. In addition to the quality problems that roads have worldwide, they also have a 3-month-long winter period to contend with, plus the extra wear caused by the spiked tyres that are permitted here. Consequently, Swedish road surfaces require an even greater wear resistance. This requirement can be met by using compact asphalt. Here in Göteborg, the 022 binder layer is laid with a thickness of 5.5 centimeters and a 016 wearing course with a thickness of 2.5 centimeters. The quality and durability that result from this innovative construction method are due to the following factors. The two top asphalt layers can be laid simultaneously, hot on hot. The long compaction time, resulting in an optimal degree of compaction. The use of high-quality additive materials in the thinner wearing course. In compact asphalt, stone chippings from the wearing course enter the surface area of the binder layer, thus ensuring optimal interlocking and bonding. The result is a deformation-resistant road surface without ruts or cracks. By using the forerunning combi feeder, the traffic flow can be maintained throughout the entire construction time. This is particularly advantageous for the road users who drive along this section daily in their thousands. With the advantages that this method offers, it's even possible to meet the high-quality demands of road construction in Northern Europe. An additional advantage of using our method is that the construction season in cold, wet Scandinavia can be extended by 2 or 3 months. From our experience with the motorway at Göteborg, we are pretty sure that our compact asphalt has now taken hold in the Swedish road construction industry. A change of construction site. Our paving and feeding equipment is heading for Holland. In the Europort, the largest port in the world, millions of tons of cargo are handled daily. The negative effect on both the roads and the environment caused by this heavy goods traffic is correspondingly high. Europe's road construction companies are hoping that this surface will help avoid the notorious jets of spray and aquaplaning and provide an effective noise reduction. The so-called silent asphalt consists of binder and wearing courses with numerous pores that can be laid with a thickness of 5 and 2 centimeters, hot on hot. The thin wearing course works as a filter, absorbing any accumulated dirt and effecting an excellent self-cleaning process. The porous binder layer directly beneath it ensures that the surface water is drained off. Noise level measurements have proved that in this road construction, using the compact asphalt method, a noise reduction of 6 decibels can be achieved. This enormous sound reduction is only possible with the compact module paver. Compact asphalt can meet all the future demands of our transport routes and creates the basis for safe, long-lasting and high-quality road surfaces. The main advantages of the compact asphalt technology: longer life cycle, standard paver with attachable modular units, construction time halved, higher quality, increased economic benefits.